Here I am with the first presentation on the basis of the seventh chapter, permutations and combination. Then let us begin this with the introduction of this chapter. And the first thing we are getting in this chapter as the principle of counting, fundamental principle of counting. Then here we have multiplication principle. Suppose if you are taking an operation A and that A can be performed in m ways, and associated with each way of performing of A, another operation you are taking as B and it is performed in n number of ways, then the total number of performance of two operations in the given order is m into n. This can be extended to any finite number of operations. If you are considering, if the situations are given and suppose we have two numbers 1 and 2, and 1 is arranged in m number of ways and 2 is arranged in n number of ways, then the total we are getting as m cross n. Similarly, the addition principle we are getting as, if an operation A can be performed in m ways and another operation S which is independent of A, and it can be performed in n ways. Another operation, we are taking the operation as B here. Another operation B which is independent of A can be performed in n ways, then A and B can be performed in m plus n ways. Means OR condition we are getting. In the first one we are getting the condition of and here we are getting the condition for OR, and this can be extended to any finite number of exclusive events. Then here in this chapter you are familiar with a word factorial. What is factorial? Then the continued product of first n natural number is called factorial n. If we have to find n factorial, then we are able to write this n factorial like this. Then n factorial written as n into n minus 1 into n minus 2 into 3 into 2 into 1 up to 1. The succeeding number, if you are observing here, then the succeeded number is 1 less than the preceding one. And the two things you have to remember, 0 factorial if you are getting, then 0 factorial is equal to 1, and 1 factorial also we are getting 1. And these two things you have to remember here. And permutation, what do you mean by permutation? Then each of the different arrangement which can be made by taking some or all of a number of object is called permutation. Suppose we have five numbers 1 2 3 4 5, and we have to write a 5-digit number, then how many different ways we have? Then we have 5 into 4 into 3 into 2 into 1, these numbers of wave. If you are multiplying these, you are getting 5 into 4 20 60 120, means 120 ways we are getting for arranging these five numbers in a 5-digit number. And if we are getting the n different object, then the number of arranging of n object taking all at a time is denoted by npn. npn, and this is equal to n factorial. Similarly, that I have shown in the last example, 5 into 4 into 3 into 2 into 1, and that is called 5 factorial. The number of an arrangement of n object taken are at a time, then this is denoted by, and where r is less than n, then we are writing npr, and it is given by n factorial upon n minus r factorial. All these things are very important when we are solving the questions, NPR is equal to n factorial upon n minus r factorial. Suppose you have to find 5p2, then this is equal to 5 factorial upon 5 minus 2 factorial. And 5 minus 2 is 3. It means that 5 factorial upon 3 factorial. And on solving this, we are getting the solution of the question. Here if you are observing some properties, we are getting here npn. If you are solving, then you are getting n into n minus 1 into n minus 2 means n factorial you are getting. And if you are finding np0, then the concept if you are using, then you are getting n factorial upon n factorial, and on solving we are getting 1. np1 we are getting n, and npn minus 1, that value is equal to n factorial. Some more properties we have, and some results we are getting. If the number of permutation of n things taken are at a time, when repetition of object is allowed, then that is equal to nr. If we have n objects and we are arranging that of n object r number of time, then we are getting the total number of arrangement as n into r, the product of that two. Similarly, the number of permutation of an object of which P1 are of one kind, P2 are of second kind, similarly Pk are of kth kind, such that P1 plus P2 plus P3, then that value is equal to n, and this is equal to n factorial upon P1 factorial upon P2 factorial, P3 up to Pk factorial. Number of permutation of n different objects taken r at a time, then npr we know this, and when a particular object is to be included in each arrangement, then this value becomes n minus 1 p r minus 1. npr we are getting when n different object taken r at a time, and if it is included, when a particular object is included, then we are getting n minus 1 p r minus 1. When a particular object is always excluded, then the number of arrangement we are getting as n minus 1 pr. Number of permutations of n different object taken all at a time when m specified object always come together is m factorial into n minus m plus 1 factorial. Make notes of all these things, then easily we are able to solve the questions. Then let us solve these questions. The first question I am taking from the first exercise. How many 3-digit number can be formed from the digit 1, 2, 3, 4, 5? These 5 different numbers are given to you, and we have to form a 3-digit number, and two conditions are given. Repetition of the digit is allowed, and in the second one, repetition of the digit is not allowed. And let us solve these questions. If you are observing here, then we have to form a 3-digit number. 100 place, 10 place, unit place we have, and the 5 digits we are getting here, 5 numbers we are getting here, and that we have to fill on the tens, hundred and ones place. Then how will you fill these? If the repetition is allowed, then by the multiplication principle, the number of ways in which 3-digit number can be formed from the given digit is, in the first one we are able to write any number out of that 5 number. Same for a second and same for a third, because the repetition is allowed. It means that the same number may occur in any of the 3 places, and the product of these we are getting as 125. Then in the second case, the repetition of digit is not allowed. It means that if unit place is filled in first, then it can be filled by any of the given 5 digit. The number of ways of filling the unit place of the 3 digit number is 5. Then the for filling the tens place, the number of ways in which the unit place digit will be filled is 5, and the number of ways in which the tens place digit will filled is 4, remaining 4 digit, and for the hundred place the remaining 3 digits. Then by the multiplication principle, the product of these three, then this we are getting as 5 into 4 into 3, and that is equal to 60. Let us solve one more question here. Question number 4. How many 5 digit telephone number can be constructed using the digit 0 to 9 if each number start with 6 7? Then if we have to form the 5 digit number and the first two digits are fixed 6 7, then these three places we have to fill, and the all, then the three vacant places we have, and out of the given numbers 0 to 9 we are able to fill unit place, tens place and hundred place for this, and this can be filled like the unit place can be filled by any of the digit from 0 to 9, but except 6 and 7 because these two numbers are fixed. Therefore the unit place can be filled in 8 different ways. From 0 to 9 we are getting 10 numbers, and out of that 10 numbers the two numbers are fixed 6 and 7, means the remaining 8 numbers we have. And on the unit place we are able to fill, we are able to write any number out of that remaining 8 numbers. On the 10 place can be filled by the remaining 7 digit, and the 100 place can be filled by remaining 6 digit. It means that a product of these three, 8 into 7 into 6, and if you are multiplying these you are getting the solution as 336. Means by the multiplication principle, the required number of ways in which 5 digit telephone number can be constructed is 336. Let us solve one more question from the exercise 7.3. Question now first we have, how many 3 digit number can be formed by using the digit 1 to 9 if no digit is repeated? This time we have to write a 3 digit number, and we have to use the digits as 1 to 9. Then let us solve this. Then if we have to form a 3 digit number by using the digit 1 to 9, the order of the digit matters. Therefore there will be as many 3 digit number as there are permutation of 9 different digits taken 3 at a time. Means out of that 9 numbers we have to take only 3 numbers. Then how will you get this? Then we are using the formula for finding the number of ways. Then out of 9 we are selecting the 3, then 9p3, 3 digits we have to fill out of that using that 9 numbers, then 9p3. And how to solve this? Then we are getting 9 factorial upon 9 minus 3 factorial, and 9 minus 3 factorial is 6 factorial. Then 9 factorial is written as 9 into 8 into 7 into 6 factorial. 6 factorial will get cancelled out, and the product of these three, 9 into 8 into 7, we are getting 504. Means 504 number of ways we are getting. Let us solve a question, one more question here. Question number 9 of the exercise 7.3. And the question is, how many words with or without meaning can be made from the letters of the word Monday? If we have to form the words by using the letters of the word, then how many letters you are getting here? We are getting MONDAY means 6 letters we are getting, and some conditions are given in the first one. 4 letters are used at a time. Out of these 6 we have to use just only 4, then easily we are getting as 6p4. In the second one, all letters are used at a time. All the letters we have to use means all these 6 letters, then 6 factorial we are getting means 6p6. And in the third one, all letters are used but first letter is a vowel. And then how many vowel we are getting here in this word Monday? O and A means only 2 vowels we are getting. Then let us solve this question. Here we have there are 6 different letters in the word Monday. Number of 4 letters word we have to form by using the letters of the word Monday. Then out of 6 different object we have to taken 4 at a time. Then 6p4. And if you are solving 6p4, then this is 6 factorial upon 6 minus 4 factorial. Means we are getting 6 factorial upon 2 factorial. And 6 factorial written as 6 into 5 into 4 into 3 into 2 factorial. These will get cancelled out. And the product of this, we are getting the solution. Find out the product. Here we have number of words that can be formed by using all the letters of the word Monday at a time. And if we have to use all the letters means all the 6 letters, then 6p6. And if you are solving this, you are getting 6 factorial. And if you are finding 6 factorial, 6 factorial is 6 into 5 into 4 into 3 into 2 into 1. And the product of these we are getting as 720. Means the required number of words that can be formed when all the letters are used at a time, then we are getting 720 words. In the third one, there are 2 different vowels that we are observing which have to occupy the rightmost place of the words formed. This can be done only in 2 ways. Since the letters cannot be repeated and the rightmost place is already occupied with a letter which is vowel, the remaining 5 places are to be filled in the remaining 5 letters, means 5 factorial ways. And if you are finding 5 factorial and we have 2 vowels, for this reason we are multiplying 5 factorial by 2. 5 factorial we know it is 120, and 120 into 2 we are getting 240. Then on the basis of these you have to solve these 2 exercise, and exercise 7.1 and exercise 7.3. The question which are based on these formulas NPR and NCR, this time this is removed from the syllabus. Means we have to solve only the statement problem, but you may solve these kinds of problem because I have explained this NPR. How will you get NPR value? Then by using the concept of NPR, NPR is equal to n factorial upon n minus r factorial. And easily you are getting the solution of these. Sai Ram to all.